Okay, so radial surveys. So a radial survey is used to create a diagram in the shape of a polygon shape with many sides. It involves drawing lines radiating out from a central point, often denoted O, which is here. Okay, so two types of radial survey. There's a plane table radial survey where they give you the angles between each distance, and there's a compass radial survey where they give you the bearing, the compass bearing here. Okay. And we're asked to find a number of things when we do in radial surveys. Okay, so the first thing we're often asked to find are areas. So I'm going to write this down. Area. For example, the area of the shape here. And we use this formula to calculate area. Area is equal to half AB sine theta. Okay, the second thing that we're asked to find are angles. Okay, and we use our bearing facts to calculate angles. So for instance, if we subtract bearings, we get the angle in the middle. That was II. And the third thing we're asked to find I are lengths. And there's a hint down the bottom for calculating lengths. The perimeter of a radial survey is calculated using the cosine rule. Okay, so let's have a look at some radial surveys. Okay, so this is a plain radial survey, and we're asked to find the area of the survey. Okay, so let's have a look. Okay, so it's going to be this piece of land here. Okay, let me just refresh your memory. Okay, so the area, we've got three areas, A1, A2, and A3. So on your calculators, you're going to do half times 100 times 89 multiplied by the sine of 100. Okay. For area 2, you're going to do half multiplied by 89 multiplied by 80 times the sine of 110. And then finally, for area 3, you're going to do half times 100 times 80. Okay, so here we use angle facts. And this one is going to be sine 150, because 100, 200, 300, and the 10 makes 60. Okay, so you're going to input these into your calculators. You're not going to work them out because that's going to give you a rounding error. That's really important. So we input each of these. I'm going to circle them into your calculators. This, and this. Okay, so once you've done that, I'm going to denote that as T. We're asked to find the nearest kilometre. So we get 9727.7 kilometres. So our final answer is going to be 9728 kilometres squared. Okay, I missed the squared there. Okay, just to reiterate, we don't work out the individual areas and then add them. We put them all in the calculator to prevent a rounding error. Okay, so let's look at another example. Okay, so I want you to pause the video and have a go at doing this, please. Okay, so you should have worked this out now. Let's have a look at the shape that's going to create. Survey, a polygon. Okay, so we need to work out these individual areas. So I'm not going to do them all. I'm just going to do this one. Call this A1, A2, A3, A4, and A5. So you're going to have 5 applications of the area formula. Okay, so let's look at A1. It's going to be half times 40 times 100 times sine of 40. Okay, so that should give you 1285.575219 meters squared. Okay, so if we input all those into the calculators, it prevents us getting a rounding error. And the final total, so we need to add up A1, A2, A3, A4, and A5. The final total is going to give 7682 meters squared to the nearest meter. Okay, so that's the end of plane table radial surveys. Let's have a look at compass radial surveys. Okay, so this one was a 2-unit HSC past paper question from 2014. Okay, so it's asking you to find the area of ABO. Okay, so this triangle, the area here. Okay, so pause the video and have a go. Okay, so you should have done that now. So the tricky bit here is to work out what this angle is here. Okay, so let's do that. We know that 021 true bearing is a measurement clockwise from north. So we know that this is 21 degrees. Okay, so we know that 310 is a measurement from there all the way around to here. So we need to add 50 to get to 360, which is the bearing here, 360 true bearing. Well, in order to get to 60, we need to add 50. So we know that this is 50 degrees. Okay, so that makes our angle 71. I'm going to erase this. .71 degrees. Okay, so the area of ABO is just simply half multiplied by 75 times 60 multiplied by sine 71. We're asked to find the nearest square meter, so that's going to give 0.27 meters squared. Okay, I think that's pretty straightforward. Let's look at another question. Okay, this one's a little bit difficult. This was taken from a Unit 2 paper, HSC 2014. So you need to know the conversion for hectares. So 1 hectare is equal to 10,000 meters squared. Okay, so pause the video and have a go at doing this, please. Okay, so you should have done that now. So the first question is show that angle AOB is 114. Okay, so we just did this. Let's extend this north. Okay, so we know that this is going to be 74, and we need to add something to this 320 to get to 360, and that's going to be 40. Okay, so we're going to add them together. 40 plus 74 is going to be 104 degrees. Okay, so I'm going to rub out my workings there. Okay, so the next one is calculate the length of the boundary AB. Okay, so I'm going to redraw this triangle. Let's use a different colour. Let's go for dark blue. Okay, so let's redraw this triangle here. So this is this triangle here. Okay, so we know that 4 degrees. We know that the length here is 211 meters, and we know that the length here is 287. Okay, let's keep this as A, keep this as B, and make that C. Okay, so let's label our triangle. We know through triangulation that this is A, this is B, and we need to find C. Okay, so this is an application of the cosine rule. Let's do this here. C squared is equal to A squared plus B squared minus 2AB cos of C. Okay, so on your calculators, square root, so 211 squared plus 287 squared, and subtract 2 times 211 times 287 cos of 114. Okay, still under the square root. So you should get C as 419.7 to the nearest meter. So we're going to write 420 meters to the nearest meter. Okay. The last and final question is find the area of triangle AOB. AOB, this is this triangle again. This triangle there. Okay, so that's pretty straightforward, and you should have done that already. So I'm going to write area is equal to half times 287 multiplied by 211 times sine of 114 degrees. Okay, so that gives 27,660.786 meters squared. Now, how do we convert that into hectares? Okay, we divide by 10,000. Okay, so we divide that by 10,000. That's going to give 27,000 hectares, 660. Okay, and it says two significant figures. Well, this to two significant figures is going to be 28 hectares. I'm going to write that in blue. 28 hectares, two significant figures. Okay, so I hope that's pretty straightforward. Nothing too complicated there. Okay, so final question. Okay, pause the video and see if you can find the distances. Okay, so let's have a look at this question. Okay, so I'm just going to change the colour for a bit of variety. So we're looking at this shape here. Okay, so first thing is to find what the various angles are. So you should have done that now. Let's insert a north. It's the wrong way. Undo. Okay, we need end. Not start. Okay, so our north is going to be here. I'm going to do this in red. Okay, so now this is 40. Now this is going to be 60. So add them together, we're going to get 100. Okay, so all this is going to be 100. Okay, we can subtract here. 170 minus 40 is 130. And then 170 to 200 is 130. Okay, and we're just going to check. We're going to do a final check that they all add up to 360. 100, 130, 130 is 360. Okay, now I want you to draw individual triangles to make sure you can find the distances. Okay, so let's have a go at doing that then. Okay, so let's consider the distance x, y. Okay, I'm going to draw this triangle in. Okay, I've got A, I've got B, and I've got C. Okay, so we're going to say C is 20, B is 15, and we're going to use the cosine rule. So let's do that then. So we've got A squared is equal to B squared plus C squared minus 2BC cos of A. Okay, let's take a square root in your calculator. That is 15 squared plus 20 squared minus 2 multiplied by 20 times 15 cos of 100. It's going to give 27.00 meters. To the nearest meter, that's going to be 27 meters. Okay, so let's consider the other distances. Okay, we need to do YZ. Let's do that then. Let's do this in green. Okay, so we got distance YZ. Okay, so let's draw the triangle in. Let's use different colours this time. Okay, so we've got this triangle here. We've got 130. Let's call this A. Call this distance A. We've got B and we've got C. Okay, we know this distance is 15. We know that b is 12. So we're going to use the cosine rule. So we're going to get a squared is equal to b squared plus c squared minus 2bc cos of a. Take the square root. B squared is 12 squared plus 15 squared minus 2 times 12 times 15 times cos of 130. Okay, so I'm just going to do this straight up. We've got 25 meters to the nearest meter. Okay, finally, we have zx. Let's do this in a different color. Okay, so zx. Okay, so let's draw this triangle in then. It's a different color. Okay, so we've got A, we've got B, and we've got C. Okay, this is 130 as well. Okay, 130. We've got B is equal to 20 meters. We've got C is equal to 12. And we need to find A. Okay, so cosine rule A squared is equal to B squared plus C squared minus 2bc cos of A. Okay, so A is equal to the square root of 20 squared plus 12 squared minus 2 times 20 times 12 multiplied by cos of 130. Okay, so we're going to get 29 meters to the nearest meter. Okay, so that's a good introduction to radial surveys, and we just need to remember three things. The first thing is the application of area. Half AB sine theta. Second is how to find the angles. Okay, so we find the angles by subtracting bearings. I'm going to write subtract bearings and angle facts. I'm going to write e.g. a circle some 360 degrees. And the final thing is the cosine rule. Okay, so those 3 points are really important and they're going to help you out in the exam. Okay, good luck and study hard.